Register now.
What's happening, people? Welcome to today's session. I hope that all of you guys are doing good. This here is Anoop and welcome to the 9th and 10th English channel. And in today's session of Gravitation, people, today we're going to be talking about a very interesting concept. We're going to understand something super duper interesting and simple as well. But it's important that you pay attention and more importantly, watch the video till the end. And do not forget to subscribe, like, share. You know the drill, people. You've been watching a lot of YouTube videos. I know you are. So you know the drill. Make sure that you do all of that as well. And in today's session, what are we going to talk about? We're going to talk about something super duper duper important. That is nothing but free fall and acceleration due to gravity. And this is one of the most important topics of this chapter. So pay attention and do not forget to watch until the end. And let me know in the comment section below how is the session going. And if they have any suggestions, let me know that as well. I'll be sure to take that up. Anyways, with that said, people, as always, there's a quote for you guys. And the quote for today is this: you don't always need a plan. Sometimes you just need to breathe, trust, and let go and see what happens. See, people, you don't have to be uptight about everything. Don't try to control all the outcomes in life. Sometimes all you need to do is relax yourself. Don't worry about the future. Don't worry about what is going to happen. Think about the present. Just calm yourselves down and see what life takes you to. That's all. Just that. Just trust and believe that the world would guide you in the right place. So don't always try to control the outcome. Don't always be so worried about what's going to happen next. Sometimes just let things go and see what happens. Alright? Anyways, with that said, let's go ahead and understand the topic for today. That is nothing but free fall and acceleration due to gravity. Now, if you haven't watched the previous videos yet, that is Kepler's law of planetary motion and universal law of gravitation, I urge you guys to watch all of that as well so that you understand what we've been dealing with in the past. And if you have someone who's struggling with these concepts, I'm pretty sure, guys, that if you watch the videos, you would understand it like superbly well. So make sure that you watch the videos as well, and do not forget to subscribe. Again, I'll keep telling this, please subscribe to the channel and make sure that you are part of the squad as well. So in the last session, that is Kepler's law of planetary motion, I'm giving you a homework. As always, every session I give you a homework, and this is the question that I asked you in the last session. Dash is time a given astronomical object takes to complete one orbit around another object. And the answer to that question, guys, is nothing but the orbital period. The time taken for an object to complete one revolution around another object, another celestial object, is what is called as the orbital period. It can be, for the Earth, we call it as 1 year, that is 365 days. So that's the orbital period. That is the time taken for the Earth to complete one revolution around the Sun. And that is what is called as the orbital period. So different planets have different orbital periods as well. Alright. So that's the case. Let's get into it. Today's topic, which is nothing but understanding about free fall and acceleration due to gravity. You see this guy jumping from an airplane for no care of life and all that? Yeah, I'm pretty sure that some of you guys are all these adrenal junkies. You want to do something exciting every day. So this is what is called as free fall. Now, what do we mean by that? Free fall is nothing but when an object is falling under the influence of gravity. Only the Earth's gravitational force, that is what is called as free fall. There should be no other force apart from gravitational force acting on that object. That is when you say that the object is free falling. It could be anything. It could be just this pen, dropping this pen. Now when the pen is being dropped, also it's only the gravitational force that is pulling the pen down, and hence I can say that it's free falling. Alright, now that you've understood this, let me tell you one thing, guys. When an object is falling because of the influence of gravity, it starts to accelerate. Now you guys know what acceleration is. You've already seen that. The rate of change of velocity. That means there is some sort of velocity on that object which is changing constantly because of the Earth's gravitational force and thus producing acceleration. This acceleration is called as the acceleration due to gravity, and this is represented by the letter small g, which shows acceleration due to gravity. Now what does it mean? Again, it is the acceleration produced on the body because of the Earth's gravitational force. That's what it is, that's all. When you think about the word acceleration due to gravity, just remember that it is nothing but the acceleration produced on the body because of the Earth's gravitational force when the body is free falling. Alright, now here's the thing, guys. Because the Earth's gravitational force is acting downwards towards the ground, because you know that acceleration is a vector quantity, so it should have a direction, and the acceleration produced on the body, that is the acceleration due to gravity, would also be pointing downwards itself because the Earth's gravitational force is acting downwards. So the direction of G is going to be downwards. Alright, now I hope you've understood so far. What did we learn so far? Let me just quickly revise it. We have seen what is free fall. That is when a body is falling freely under the influence of gravity, that is called as free falling. And when the body is falling freely like that, there is acceleration produced on it, and that acceleration is called as acceleration due to gravity, which is represented by the small letter g. And apart from that, we also saw that the direction of this acceleration due to gravity is acting downwards because the Earth's gravitational force is acting downwards. Now the question is this: how do we find out the value of g, which is nothing but acceleration due to gravity? How do you calculate it? If you're asked to find out acceleration due to gravity, how do you calculate it? Now we all know that force is equal to mass into acceleration. So let's assume that there's a ball falling freely. Let's say that this is you, all right? Like you're Superman with everything, with the cape and everything, all right? That's you. That's the cape, all right? It's not a trapezium or anything. That's a cape, and you're like standing and you just drop the ball. So let's say the ball has a mass m, because obviously it's made up of matter, so it has a mass which is m, and it is placed at a certain height h from the ground. Now what happens is that because of gravitation or the gravitational force, the ball with that mass starts to fall down. Now because of the force acting on it, there's some sort of acceleration produced on it. Now we have already seen that in the Newton's law of motion, that the second law of motion says that force is equal to mass times acceleration. Now here acceleration is acceleration due to gravitation, and hence A becomes g. So what do I get? F is equal to m into g. That's what I'm going to get, right? Simple so far. Now in the previous session we also saw that the gravitational force is equal to the universal gravitational constant into the mass, or the product of the two masses, divided by the square of the distance between the two objects. We've already seen this in the previous session. So we saw that force is equal to what? The universal gravitational constant into the product of the two masses divided by the square of the distance between them. So far so good. Where r is nothing but the radius of the Earth, m is nothing but the capital M is the mass of the Earth, and small m is the mass of the ball. So far so good. We have seen that. Now force is equal to mass to acceleration. Force is also equal to, that is the force of gravitation is equal to g into mm divided by r square. So what I'm going to do, I am going to substitute this value, or I can put this value in place of this one, either of these, right? In place of the first equation or in the second equation, I can just substitute it. So what I'm going to get, let's say that I'm going to substitute this first equation in the second one. So what will I get? mg is equal to gmm divided by r squared. Now mm gets cancelled. So what are you left with? Acceleration due to gravity is equal to the universal gravitational constant into the mass of the Earth divided by the radius of the Earth. Simple as. Now what I'm trying to say is this: when you talk about acceleration due to gravity, it depends on the mass and the radius of the planet. If either one of these quantities change, if the mass changes or if the radius changes, then the acceleration due to gravity would also change along with it, because it's completely dependent on the mass of the object, sorry, mass of the Earth, and the mass of the radius of the Earth. Now if you talk about another planet which has a different mass and a different radius, that would have a different acceleration due to gravity. Every planet has its own acceleration due to gravity because every planet's mass is different and radius also is different. Are we good? Okay, now that you've understood this, let me tell you one common thing that we should remember this. All right. Now We know that the universal gravitational constant is 6.7 into 10 to the power minus 11 Newton meter square per kg square. We've seen this in the past. We also know that the mass of the earth, which remains constant, is 6 into 10 to the power 24 kg. We also know that the radius of the earth is 6.4 into 10 to the power 6 meters. So we substitute all the values, that is g is equal to 6.7 into 10 to the power of minus 11 into the mass of the earth, that is 6 into 10 to the power of 24 divided by 6.4 into 10 to the power of 6 meters. What you get if you subtract and divide and everything, what you get is basically g is equal to 9.8 meter per second square. Now this is the acceleration of the gravity. Now obviously I'm just stopping at one decimal point. It goes on, but then yes guys, this is the value of acceleration to gravity. In some cases what we do is that because it's 9.8, you can just take it as 10 meter per second square as well. Like it's very close, so you can just take it as 10 meter per second square. But in most cases you would be asked to take the value as 9.8 meter per second square itself, or is there a mention that you can take it as 9.8 or you can take it as 10 meter per second square in the questions that I'll be doing, the numericals. No, they'll be asking you, they've mentioned it. If they have not mentioned it, you can just take it as 9.8 or you can take it as 10 to make your life a little bit easier. It does not make much difference. The point values might differ, but then it's very close, so you don't have to worry about it, right? So 9.8 meter per second square is the acceleration due to gravity acting on an object when a body is free falling because of the Earth's gravitational force. Alright, now the question is this guys, what would happen if you were to vary the distance? Now, we all know that Earth is not a sphere, right? It's not a perfect sphere. It's what you call as an ellipsoid. So what is happening? It's like basically crushed from both the sides. So the poles are a little flattened, and the equators on the other hand is a little bulge. You see this? So the radius towards the pole is actually much lesser compared to the radius to the equator. The radius of the equator from the center of the Earth is far more greater than the radius of the Earth to the pole. Now, because there is a variation in radius, don't you think the acceleration to gravity would also differ? Because remember, acceleration to gravity is gm by r square. So if r square is varying, don't you think that the value of g will also differ? Absolutely. Remember this guys, the acceleration due to gravity in the poles is actually much more than that at the equator. Why is that so? Because the Earth's radius, or the radius towards the pole from the center of the Earth to the pole, is actually much lesser in comparison to the radius or from the center of the Earth to the equator. Because the radius is more, the acceleration due to gravity is less. Because you see this, it's indirectly proportional. So if this increases, this must decrease. So the radius increases, then the acceleration due to gravity decreases. That means in the equator, the value of g is less, and in the poles, the value of g is more. Again, why? Because in the poles, the radius is far lesser, and hence the acceleration to gravity is far greater. Simple guys. Now again, there's not much difference. It's not like there's night and day wala difference, but there is still a difference between them. So remember that, people. It's super duper important that you remember all of these, and like I told you, watch till the end so that you understand everything. We'll also be solving a lot of problems as well. So yes guys, as we go from the equators to the poles, the value of acceleration to gravity increases, and as you go from the poles to the equator, you see that the value of g decreases. Alright people, so one more important thing that I want to tell you is nothing but the variation of g with respect to height again. Now in this case, let's say there's a spacecraft, alright, because obviously spacecrafts are trying to get away from the Earth's surface, and obviously because of that there is some sort of gravitation, or there's some sort of acceleration to gravity acting on that as well. So how do you calculate that? See guys, we know that the radius of the Earth is represented as r. Now if the spacecraft or that aircraft is at a certain height, so it is at a certain height from the Earth's surface, which will just take it as h, small h, which represents what is the height of the object from the Earth's surface. So if I want to find out what is the acceleration due to gravity acting on that object at that height h, all I have to do is this: add the radius of the Earth and whatever is the height and square that value. You would get what is the acceleration to gravity acting on that object. Now how did I come to this conclusion? Because see this guys, it's very clear that g is equal to gm by r square. Now in this case, it is not just the radius of the earth because the object is not on the surface of the earth. So you cannot just take that value and tell that this is the acceleration of the acceleration due to gravity acting on that object. It is at a certain height from the earth's surface. So you have to add that height as well. So when you add it up, you will get it as r plus h the whole square, where h is nothing but height of the object from the level, from the earth's surface. That tells you what is the value of acceleration due to gravity acting on an object at a certain height, like maybe the International Space Station or a spacecraft that has been just launched from a launch site. So all of that you can calculate by using this one simple formula. Right, guys? Now once again, just to recap what all you've seen so far. If you talk about the acceleration due to gravity, once again the formula is this: gm by r square, where g is nothing but the universal law of gravitation or universal gravitational constant, and m is nothing but the mass of the earth, and r is the radius of the earth. And if you were talking about an object at a certain height, then the acceleration due to gravity on that object would be, the formula would slightly vary, where r just becomes r plus h, which is the height of the object from that from the earth's surface. That's all, people. So as as you increase the height, the value of gravitational due to gravity, acceleration due to gravity would also decrease. As you decrease the height, the value of acceleration due to gravity would actually increase. That's it, people. Now, one more important thing that I would like to say is nothing but motion due to gravity. This is the last topic, guys. The thing is this, guys. If the object is acting in the direction of the gravitational force, which is downwards, then the acceleration to gravity is going to be positive, because I told you this, that the gravitational force is acting downwards. You also know this. For example, why does the pen fall down? Because the acceleration to gravity or gravitational force is acting downwards. So the acceleration due to gravity is going to be in the same direction. If it is in the same direction, then it's positive. But on the other hand, if you were to toss the pen up, now this is going against gravity, so the acceleration produced on that would be negative. Why? Because it's going away, or it's opposing the gravitational force, and hence the value is going to be negative. So if it's in the same direction of the gravitational force, then it's positive. If it's in the opposite direction, then it's negative. That's all, people. That is all that I had to teach you guys. Now, yes, we will have some interesting questions to solve as well, and those questions are super duper important. We'll be solving some questions as well, problems as well. So listen very, very carefully, guys. But before we get into those questions and start testing our knowledge, I have very important announcement to make. So listen very carefully for the next 5 minutes. This is definitely going to help you in the future. So listen very, very carefully. Here's the thing, people. You know that your life has changed a lot since the quarantine, right? So you guys are facing a lot of problems. You guys are struggling with a lot of things. Few things have been made easier, but few things, like especially when it comes to studies, things have changed a lot because you're used to the conventional way of studying, go to the school and stuff like that. So that has become a very big issue. So we were actually very concerned, and we actually put up a poll asking you people what are the problems that you people are facing during this quarantine time, so that we can help you guys a little better. So these are the things that you guys came up with. One, doubts, right? Because your doubts are not getting cleared on time. There are a lot of websites out there, but then it takes about 24 hours to 48 hours to get your doubts cleared, and you don't want to wait for 2 days to get your doubts cleared. Secondly, notes, because you are studying from a lot of YouTube channels and a lot of other online platforms, but then getting the notes that the teacher has written, the handwritten notes of the teacher, has become a very big issue. Thirdly, tests and assignments, because you don't want to go and sit in front of the exam hall without practice. You want to know whether you're good at the topic or not, and for that, tests and assignments are a very integral part of it. Fourthly, competitive exams, because your NTSCs is right around the corner, and you're planning to give a lot of competitive exams. So how do you train yourself for that? Fifth, choice of your own schedule, because that has also become a very big issue. You're not free when the teacher's free, when the class is going on. You might not feel like studying. So this always is conflict of interest, a conflict of schedule happening all throughout the day. This is something that happens to every one of us. And finally, but definitely not the least, choice of your own language. That is, how do you study in a language that makes you comfortable and not the teachers comfortable in? Now, these are all the problems. But what is the solution? Problems, so yes sir, you told it. But what is the solution? Don't worry, people. Vedantu's here. We have successfully solved all of your problems. Inside the class, you will not just have the master teacher. Obviously, the master teacher would be there to clear your conceptual doubts and help you understand the concept. But At the same time, we'll also have someone called as a class teacher. Now, the class teacher's job is to make sure that your doubts are cleared inside the class itself. So you don't walk out of the class with more confusion. Instead, you walk out of the class with a clear knowledge of to what you've understood inside the class. You can download all the notes and watch every single recordings of every session. So there's no worry about whether you'll be able to download what the teacher has written, any equations. Don't worry about all of that, guys. Everything is covered. You can download all the notes, how many of a number of times you want, and watch all the recordings as well. So you guys are covered with that as well. You have regular tests and assignments, and based on these tests and assignments, you will also be getting a detailed report card of what you have done in those tests. What are the topics you're strong at? What are the topics that you're weak at? Every single detail will be there in that report card. With that said, you'll also be trained for competitive exams, your NTACs, IMO, ISOs, everything. You'll be trained for that as well. You can choose your own schedule. There is no need to come at the teacher's timing. Whenever you feel like studying, at 7 o'clock, go ahead, do it. You want to do it at 9 o'clock, go ahead and do it. Nobody is going to stop you but yourself, because India is a free country and you get to choose what you want to do. And lastly, definitely not the least, guys, you can choose your own language. If you're someone who's comfortable in Hindi, you can study in that medium of communication. If you're someone who's comfortable in English, you can study with that as well. We're not offering all the regional languages as of now. Maybe in the future we might, but for now it's restricted to Hindi and English. So if you're someone comfortable with any of these two languages, you can go with that as well. And together with all of these people, you have unlimited live classes. All micro courses and crash courses are free, a detailed performance report card like I told you, and personalized attention with the help of the class teacher. So what you have to do, is that what you're asking me right now? All you have to do is click on the link that is given in the description below. It'll be the first thing on the description and also be pinned in the comment as well. So what you have to do is just click on that link. Once you click on that link, this is what you're going to get. Every detail would be asked in this. Which grade are you in? Let's say you're in 10th grade. Once you click on it, they'll ask you which board do you belong to. These are the 3 boards at this point of time that we are offering sessions to: CBSE, ICSE and Maharashtra board. Let's say you're in CBSE. Once you click on CBSE, this is what you're going to get. Every detail that I just told you, with even more details, you can find this on this single sheet of paper. So what you do is click on get subscription. Once you click on get subscription, guys, this is what you're gonna get: 1, 3 and 6 months course. Now think about it, guys. You'll be studying in the best of the best online platforms with quizzes in every single session. It'll be a super interactive two-way connection. It's not like the teacher's just talking. No, you'll have a two-way communication where you can interact with the teacher. You get tons and tons of options. So do check out the link. Do not forget about it. So let's say that you're if you want to go for the 1 month course, you want to enroll into the 1 month program and see how it works out for you people. For the 1 month program, the base price of that is 4,000 rupees, which is pretty expensive. To make it more affordable so that every single child gets the power of education, we have brought the price down to 2,699 rupees, which again seems like a lot of money. So if you want to get more discount on that, enter the coupon code AMEPRO and you get additional 539 rupees discount, and the base price of that comes down to 2,159 rupees for the whole month. Now I know that 2,000 seems like a lot of money, but think about it, guys. The best of the best platform is what you're going to be studying for just a mere price of 2,000 rupees, which we spend on a single shirt. So yes, it is actually less to spend on your own future. Let's see what of the 3-month program. The 3-month program, the base price of that is 10,000 rupees. Again, the base price comes down because we want to make it more affordable so that all of you guys get a chance to take a part in this, in this life-changing opportunity. It'll come down to 6,999. On top of that, if you use the coupon code AMEPRO, you get additional 1,399 rupees discount. So the base price of that comes down to 5,599 rupees for the next 3 months. Let's say we're going to the 6-month program. For the 6-month program, the base price of that is 16,000 rupees, which is a lot of money. So base price falls down to 11,499. On top of that, if you use the coupon code AMEPRO, you get additional 2,299 rupees discount on that, and what you'll be paying essentially for the next 6 months is going to be 9,199 rupees. Do check out the link. It'll be given in the description below, and do not forget the coupon code AMEPRO to avail all those amazing discounts as well. Alright guys, so with that being said, let's look into some questions now. I want everyone to try out these questions on your own, and most importantly, let me know in the comment section below if these questions were hard for you to solve or was it too easy. And also let me know what are the answers that you got, whether it's right or wrong, it's okay. Let me know in the comment section below what are the answers that you got. I'll be hoping to see your comments as well. So with that said, people, here is your first question. Go ahead, look at it, let me know what is the answer in the comment section. Just write A, B, C or D. Let's see how many players are able to give it bang on. Now again guys, don't cheat. Pause the video and then answer the question. I don't want anyone to cheat. Alright, here's the question. The atmosphere is held to the earth by what? Gravity, wind, clouds, or the earth's magnetic field? What is the one thing that holds the earth's atmosphere? And the answer, you know it, people, I know it, everyone knows it. The nation wants to know. The answer is nothing but gravity. It's definitely gravity. Gravity is the reason why the earth's atmosphere is held onto the earth itself. Think about it. The moon does not have any gravity. It has gravity, but it does not have any atmosphere of its own because the gravitational force is not that strong to have its own atmosphere, whereas earth on the other hand can have its own atmosphere. Second question, the acceleration due to gravity on the earth depends upon the what? The mass of the body, the mass of the earth, the shape and size of the body, or the volume of the earth. The acceleration due to gravity on the earth depends on what? Remember the formula, guys? G is equal to gm by r square, where m is the mass of the earth and r is the radius of the earth. So what is the one thing that it depends on? The mass of the earth, people, no doubt about it. It does not depend on the mass of the body. It does not matter which body it is. Every body, no matter if it's a feather or if it's a ball, it would all drop down at the same, it'll all have the same acceleration to gravity, that is 9.8 meter per second square itself. Does not matter what object it is, it's going to have the same acceleration to gravity. Third question, guys. The value of acceleration to gravity is the same and on the equators as well as the poles. Is least in the poles, is least at the equator, or increases from pole to the equator? And the answer, people, is going to be option number C. It's least in the equator. Why? Because the earth is bulged. The radius of the earth in the equator is more compared to that of the poles, and hence it's going to be option number C. It decreases as you go from poles to the equator because again the radius at the equator is going to be far more greater than that of the poles. That's it, people. With that said, now here are some level 3 questions for you, people. These are basically the questions that will be asked as 5-mark and 4-mark questions, wherein you have to solve some questions. Now, to solve these questions, people, you need to remember 3 important formulas. And those are nothing but the equations of motion that you've studied in the previous chapters that you have seen. That is, V is equal to the first equation, sorry about that, V is equal to U plus GT, where G is nothing but acceleration to gravity, or V is equal to U plus AT. Now A is nothing but acceleration to gravity, so A is equal to G, so in place of A, I'll substitute as G in all the 3 equations. Second equation is S is equal to UT plus half GT square, not AT square, GT square. And thirdly, V square is equal to U square plus 2GH or 2GS, right? So these are the 3 equations that you need to know. If you remember these 3 equations, these questions are going to be super damn easy, guys. All you have to do is substitute the values and you'll get the answer. Here's the first one. A ball is thrown vertically upwards with a velocity of 49 meters per second. Calculate the maximum height as to where it reaches and the total time taken for it to return to the Earth's surface. Your options are 122.5 meters and 10 seconds, 122.5 meters and 5 seconds, 111 meters and 10 seconds, or 100 meters and 5 seconds. How do you solve this question? Very simple, guys. Now, they have given you what is the initial velocity. They've given you what is the value of U. U is 49 meter per second. You also find out what is the maximum height that the body reaches. Now, at the maximum height, the value of V is going to be 0 because the final velocity is going to be 0, because once it reaches the maximum height, the body stops basically. It just stops there and then it comes back down. So the maximum height, the final velocity is going to be 0. So calculate what is the maximum height. Which formula do you think would be the best suited for this? 1, 2 or 3? If you ask me, I would go with the third equation of motion. V square is equal to U square plus 2GH. So I have to find out what is the value of H. So V square is 0, U is 49 square plus 2 into, I'll take the value of G as 9.8 meter per second. So it will do into 9.8 into H, meter per second square, into H. So 49 square, if you 49 to 49 is 2901 plus 9.8 into 2 is 16. Sorry, not 16. I think it's around 19.6 or 16.9. I'm not really sure. Just check the value though. 19.6 into h. So h is equal to 2901 divided by 19.6. So if you divide it, you'll get it as something like 122.5 meters as the right answer. I might have made some calculation mistake, but do check it, guys. Forgive me for my mathematics. My math skills are pretty awesome, so you know the drill. So yes, guys, so that is the answer that you're gonna get. It'll be around 122.5 meters. Now to talk about the time taken. To calculate the time taken, what I'm gonna do is I'm gonna use the first equation of motion. V is equal to u plus at to find out gt, to find out the time taken. V is 0, use 49 plus 9.8 into t. So t is equal to minus 49 divided by 9.8. Now just ignore the signs because of the fact that time cannot be negative. So it will be 9.8 and 4.9 divided by 49 divided by 9.8, which will be around 5 seconds. Now this is the time taken for it to reach the maximum height. So what is the total time taken? It has to go up and come down. The question is, what is the total time taken for it to return back to the Earth's surface? So that will be 2. If it takes 5 seconds to go for it to go up, then it will take 5 seconds for it to come back down as well. So the total time taken would be 5 plus 5. That's 10 seconds. That's all, guys. And the answer to this question would be option number A, with 122.5 meters as the height, maximum height that it reaches, and time taken is 10 seconds. Congratulations to all the guys who actually managed to solve this question. It's a pretty easy one, just that you have to remember these questions, these formulas, and substitute right and get the calculation correct. All right, last question, guys. The mass of the moon is given as 7.31 into 10 to the power 22 kgs. If the radius of the moon is 1.7 into 10 to the power 6 meters, determine what is the acceleration due to gravity, and the value of g, that is universal gravitational constant, is given as 6.7 into 10 to the power minus 11 Newton meter square kg square. Your options are 9.8 meter per second square, 1.54 meter per second square, 1.22 meter per second square, or 1.72 meter per second square. So first of all, write down the given data. M, that is the mass of the moon, is given as 7.31 into 10 to the power of 22 kg. The radius of the moon is given as 1.7 into 10 to the power of 6 meters. They have given you the acceleration to gravity. Suppose to find out what is the acceleration to gravity. So G is equal to Gm by R square. So G is 6.7 into 10 to the power of minus 11 into mass is 7.31 into 10 to the power of 22 divided by 1.7 to the power of 6 meters. Okay, you have to square that as well. So what are you going to get if you simplify this? Subtract all the exponents first. So 6.7 into 7.31 into 10 to the power of 11, 22 minus 11 is 11, divided by 1.7 into 1.7 into 10 to the power of 12. So if you simplify this, you would get if you multiply all of these, you'll get as 1 point. Okay, I think yes, you can do the calculation part, people. My mathematics is pretty bad. So if you multiply 6.7 into 7.31, you'll get something as 48.9 into 10 to the power of 11 divided by 2.89, that is 1.7 into 1.7 into 10 to the power of 12. So if you simplify this, you will get the answer something as 1.69 or 1.7, something like that is what you're going to get. So that here would be the answer for this question. So 1.69, 1.72 is what you're going to get. So the answer to this question would be G is equal to 1.72 meter per second square. I'm sorry for the calculation, guys, because if I start doing this, this would take me like maybe a couple of days to finish this off, just to avoid that, because I'm pretty sure that you don't want to see me sit and calculate and make mistakes again and again. So yeah, people, that will be the answer. It'll be 1.72 meter per second. That is the closest value to 1.69. So again, it's 1.72 meter per second square. So that there is the acceleration due to gravity on the moon, people. So like I told you, every planet has its own acceleration due to gravity because every planet's mass is different and the radius is also different. So that's it, people. That is it. This is your homework for today. Let me know what is the answer in the comment section below. The question is, the value of acceleration to gravity on the surface of the Earth at sea level is what? What is the value of acceleration to gravity on the surface of the Earth at sea levels? Let me know what is the answer in the comment section below. Once again, people, do not forget to like, share, and subscribe. Be a part of the squad. And also, guys, I have a very amazing, super califragilistic expediamus news for you guys. we are going to have the master scholarship admission test for all of you guys out there, with a admission scholarship of around 100 crores. Around 100 crores is what the scholarship amount is this year, wherein all you have to do is take part on the test that you have on every Sunday at 3 p.m. and this is going to start from 25th of October, which means it has already started, and it will go on till 29th of November, and the grades are from 6th to 13th grade. So you will be getting a scholarship, a complete 100% scholarship for your JEE NEET as well as CBSE preparations as well. This is going to completely change your life. All you have to do is log into the website, enroll into the scholarship test, and take part in the quiz. Just take 2 to 3 hours. It'll take about 2 to 3 hours for the admission test. Do take part of the test. The more higher the scores are, the more scholarships you get. But I'm pretty sure that every one of you guys have the capability to walk out with a 100% scholarship. So all you have to do is this, people, go to your Vedantu website and enroll into the admission test as well. Now, these are some of our results that we've achieved last year, and this year, people, I'm pretty sure that it will be more than what we've done last year. Again, like, the link would be there in the description below. Do check out the admission scholarship test as well. That's it from my side, guys. Once again, I'll see you guys in the next one. Do not forget to like, share, and subscribe. And until the next time we meet, peace out, enjoy yourself, stay safe, and belated happy Children's Day and Diwali celebrations as well. Take care, guys. Bye bye. See you all.